Okay, at the end of the last video I said we'll do the inverse matrix. Actually, we're doing the matrix equation, but we do that using the inverse matrix. And again, we've been over that very thoroughly. So you can review earlier videos. We'll go through this a little more quickly than usual. Our system, written in matrix form, is this. And you can easily verify that. So here it is. Now, this is an equation in the form A times x vector equals b vector, where A is this matrix, x vector is this column xy, and b vector is this column -2, 19. We solve this by, well, if this was a equation with numbers and simple variables, you'd want to divide both sides by A to get x. Okay, well, we can't divide, A is a matrix, we can't divide by a matrix, but we can do the analogous thing. We can multiply the matrix by its reciprocal, I'm sorry, by its inverse reciprocally. It kind of feels that way, but it's the inverse. Okay, we multiply this A here by its inverse, and that essentially cancels it out. Now, that's because A inverse times A is the identity matrix, as we saw earlier. And the identity matrix times the x vector is just the x vector. Now, I didn't include the step that shows this is identity times x. And the identity times x is x. So there's a step missing in here, but review what we did originally where we wrote it out in all its detail. Now, that gets me x. All I've got to do is do the same thing to this side that I did to this side. Well, here's the equation. What did I do to this side? I multiplied on the left by A inverse. So I have to multiply whatever's on this side on the left by A inverse. I have to multiply both on the left. If I try to do B times A inverse, well, that doesn't work because matrix multiplication is not commutative. The order in which you multiply two matrices is very important. It almost always makes a difference if you change the order. Not only that, if you change the order and wrote B times A inverse, you couldn't even multiply them because the rows of B only have one number in them. First row has just a -2, second row has a 19. You'd have to multiply a row of B by a column of A, and the columns of A have two numbers. You can't do that. You can't multiply a row consisting of one number by a column consisting of two numbers. You have to be able to match up the numbers, the first number in the row with the first number in the column, second number in the row with the second number in the column. And I'll say that, as of today, people need to get a little more used to matrix multiplication so we know these things. Okay, not too hard to do this if you're shaky in matrix multiplication, but you're going to have to do matrix multiplication. And have to know when matrices are consistent. So, end of that digression, we multiplied this side by A inverse, we have to multiply this side by A inverse, and we put the A inverse on the left so it would be matched up with the A. So we're going to have to put the A inverse on the left here because that's how we did it on this side. Okay, so this simplifies to x, and then x is going to be A inverse times B. So all we have to do is we have to write down A inverse. Now, for a bigger matrix, that's a little trickier, but for a 2x2 matrix, we have the simple rule that we went over in much detail. We just flip the main diagonal, and we change the signs of the second diagonal. And that gives us the matrix. Well, if we flip the 4, 7, we get a 7, 4. And change the signs of the -3 and 5, we get 3 and -5. So we flipped the main diagonal here, and we changed the signs of the secondary diagonal. And we also have to divide by the determinant of this matrix. And the determinant is just multiply the numbers in the main diagonal, and then multiply the numbers in the secondary diagonal, and do the product you got from the main diagonal minus the product you got from the secondary diagonal. And that, again, we went over that in complete detail, even to the point of indicating how you prove that that works. Okay, Well, no, we didn't really prove why the determinant works. That goes a little deeper than we can go here. But anyhow, that's how you do the inverse matrix. You simply have to know that. And so the determinant turns out to be, well, 4 times 7 is 28. Negative 3 times 5 is negative 15. So we're going to do 28 minus the negative 15, which is 28 plus 15, which is 43. So we divide this matrix by 43, because 43 is this determinant, meaning we divide every element of the matrix by 43. Now, this is what we get. I don't have to read it to you. It's clear that this is it. Okay, well, that's the A inverse matrix. This sequence tells us what to do with it. We start, again, I rewrote the equation, same as this one, but I want to be able to just kind of move down the board. So here's the equation. Now in purple, I wrote the inverse matrix on the left of the left-hand side, and then I wrote it on the left on the right-hand side. Now all we have to do is know how to multiply matrices. You can verify if I multiply this row by this column, I get 1. You have to do the fractions. If I multiply this row by this column, I get 0. If I multiply this row by this column, I get 0. If I multiply this row by this column, I get 1. So this times this gives me the identity. Now that's what inverses do. Okay, if you got the inverse right, then when you multiply the two matrices, you will get the identity. So don't just be writing down the identity. Make sure you do that multiplication and make sure it really gives you the identity. Otherwise, your solution is going to be screwed up. And if I don't see where you did that multiplication, you're not going to get a lot of sympathy. Yeah, I might love you, but I'm going to penalize you, okay? You got to do this right. Okay. Now, on the right-hand side, we multiply, okay? Now, if you wrote these down wrong, which, you know, put this thing on the right, again, as I said before, you can't multiply it. Okay, I do the first row by the first column, and I get, you know, this times this gives me negative 14 over 43. This times this gives me 3 times 19 is 57, gives me 57 over 43. I've got to add what I get, you know, I got to add this, the product of the first elements to the product of the second elements. So there it is. Okay, then down here I do the same thing. Negative 5 over 43 times negative 2 is, well, negative 5 times negative 2 is 10. You get 10 over 43. And you get 4 times 19 over 43. 4 times 19 is 76. So you get 76 over 43. And you got the plus. Then, well, we add these up, we get 43 over 43. We add these up, we get 86 over 43, and you've seen these numbers before. 43 over 43 gives you 1, 86 over 43 gives you 2. One more step then. The right-hand side here is going to be 1, 2. The left-hand side, well, 1, 0 multiplied by xy gives me 1x plus 0y, that's just x. And 0, 1 times xy gives me 0 times x plus 1 times y, that's just y. So we have the column xy equal to the column 1, 2. Follows that x equals 1 and y equals 2. And that's the same solution we got for the other three accurate methods, and reasonably close to the estimate we got from the graphical method. Now, those 4 things, okay? You got to know how to do those 4, and if I ask you to do all 4 in a test, you're going to have to do all 4. If I ask you to do just one, you got to do the one I asked. Now, as I said, if I ask you to do one method and you don't remember how to do that method, well, do all 3 of the others, and you're not going to get full credit, but I'll be reasonably generous. Okay? But you know what you need to do for full credit is do what I ask. Okay, do what the problem says, and if you can't, do something and hope for mercy. I am reasonably merciful if you're addressing the correct problem. Okay.